How's it going, everybody? In this video, we're going to take a look at some stuff when it comes to troubleshooting. So we're going to do some looking at iOS troubleshooting tools, applying troubleshooting methodologies, and interpreting packet captures. So it's going to be just a high-level overview of how things work, and we're going to deep dive a little bit into it. We're not going to do any command line implementations in the written section. We're just going to take a look at how things work from a conceptual understanding, and then when we get into the actual implementation and stuff, the lab side of it, so the learning process of going through, I'm going to be spending a lot of time deep diving the technologies and stuff like that. I've already released a couple with RIP and IP routing because they're pretty straightforward, but when we get into troubleshooting, things like that, we'll look at packet captures and stuff like that, performance monitoring and things of that nature. And then when we get into, like I said, once we get through the learn section, all the major topics, and then we'll go back through and do I have some CCIE labs that we're going to run through and stuff like that. But I'll get into those in an upcoming video. But when it comes to some of the troubleshooting tools we have, actually, if you were to download, actually, let me pull it over here. If you were to download off of Cisco's website, let me bring it over here into the shot here real quick. What I've done is I basically just copied and pasted from the blueprint that Cisco has provided for us. I basically just copied this in, and we're right here. So, troubleshooting tools, applying troubleshooting methodologies, and interpreting packet captures. We're going to run through each one of these. I've broken it down in the videos that you see here in front of you. And we're going to run through each one of these, what each one is, kind of how it works. And then when we get into it, I will run through these on a regular basis. I'll actually use this as my, knowing what they are and knowing that the option is there is one thing, but knowing when to use them is going to be another thing. That's what we're going to talk about throughout our videos here. But move that out of the way here. So, debug and conditional debug. Now, if you haven't used a debug, it can be one of those scary things if you've never touched one. Typically, they're frowned upon in a production environment, but I live by them when it comes to learning a new technology, seeing how the iOS actually processes everything. You know, if something's not working, after a couple of minutes of me doing some show commands and some pings and traces, I'll start doing a debug. Is it something that the show command won't throw an output on? And that's one of those things where if you don't know all the show commands for a particular technology, like let's say for instance RIP, you don't know what every show command is for everything you need to verify for RIP, then that's something I would know first before you go do a debug. Second of all, in production, make sure that the resources on the device aren't very high. So I'll give you an example of this. Let me pull over. Actually, I've got my rack, my ESXi rack is running right now, and I was just making sure that I had some options here. But it's kind of hard to do this on a Cisco on a virtual router in GNS3 because there really is no file system, so to speak. So if you were to do a show proc CPU sorted and hit enter, you're going to get the output for the last, however many minutes. So we have 4 seconds, 0. We have a 5-minute interval, a 1-minute interval, and a 5-minute or 5-second, 1 minute, and 5-minute interval. And depending on what's going on, will determine what you get. So as you can see, most of what we have here is let's see, we have ARP, Ceph, multicast listener discovery, things like that. So a lot of it's very, very basic, and nothing's real high, very, very limited at best. But knowing how to go in and find this information is going to be good, so you can see, is a debug okay to run? And then if I was you, I would do, if you go to config T and type in logging, buffer, and you were to specify the level you want to debug at, you could go say you want a logging buffer 7, and you could say, and then if you were to hit enter and then do logging console 6, so it's going to send all debugs to the buffer, and which is going to be your show log, and then you can do why am I having a brain fart? you could do all of your informational and below. You could do everything from there. You could do to the console. So link up, link down, things like that. So move that out of the way here. Conditional debug they can restrict the output of the debug. So a debug match a condition that debug is matched. That debug that is matched will be shown. Basically, a fancy way for you to restrict what you can debug. So if you were to do, let me bring this down just a bit, because that's kind of a, I've never actually used conditional debug, but it's an option that's out there. So if you were to go, I believe it is debug condition. Yeah, debug condition right here. Debug condition, question mark, and then you would specify what you want to debug, what your debug would be. So if you want to debug IP and you know, was a 8.8.8.8 and you question mark, you can do that. You can. There's several other things. I would play around with this because you never know what you're going to have to work with. But there's not a lot of stuff that you can really work with. So read up on that as well, just so you're aware that these are options that are out there. Now, ping and traceroute are a little, and just to save my own skin, I don't use conditional debugging. If I'm going to do a debug, I'm going to do it. I'm going to send it to a syslog server. Is what I do. I debug. I'll log. I'll send all of my. First of all, I'll log to the buffer, and then the buffer is sent to a syslog server. So then I'll log into the syslog server, and I'll look at the syslog outputs, and I'll go, okay, there's our problem. I don't do anything locally because, one, I don't want the console to get overran, and two, the buffer is there for events on the device locally. So if something goes down, I can jump onto the box and say, okay, show log, what happened? I had a link up, link down, or a power cycle. Typically, it's going to show you a power cycle. If you do a show ver, actually it hasn't done it here because you can't really do this here. If you do a show ver, right here, last reload set, unknown reason. This guy right here, if there was a reload, which is actually what ended up happening is I lost power to my server and it crashed. So that's why it doesn't know specifically what happened. But let's say there was a power outage, it would say power. If it was a software issue, it would give you some sort of error code that you could do a check on Cisco's website to an error something or other. I forget. I'll look that up for you. But ping and traceroute with extended options. So what are the options? Why would you want options? Well, because you can get specific with your options. You can go in there and you can set the source interface, things like that. It's going to be a really cool thing for you to do if you want to get specific with something. Say, for instance, you're testing a theory on. Just recently, I wanted to see if anything, any traffic was matching EF. So if I wanted to match any traffic marked as EF for voice, so I made an ACL, and then I pinged through the network, and I did a trace route, and I specified, a ping, and I marked it as CS5, and I went through and I was getting matches. So on that, and then I realized that it was the pings that were getting checked when I did a packet capture. And so, long story short, knowing the different options, and actually I'll show you quickly how to do this because it's one of those more on the. So we type in ping and hit enter. You're going to ping IP protocol, and then you're going to say the target IP address for us is going to be 8.8.8.8. And we're going to do question mark or enter. Repeat count 5. You can change that. You can say 10. You can say a datagram size is always going to be 100 bytes. You can say 1500 for maximum MTU. Timeout in 2 seconds. You can say that's fine. Extended commands. If you want to say yes, hit enter. And say source address of interface. Do that. Whatever that might be. If you don't want to change the source address, you don't have to. Type of service. If you want to type in 5, you could do that. DF is the do not fragment bit. So if you want to change it to make sure that it doesn't get fragmented, so you want to know, let's say for instance you're trying to figure out the MTU between two different interfaces, or you think there might be some issue in the network and you're not sure what exactly the problem is. Checking MTU might be the problem, and depending on what you have running in your network, MTU could become an issue. So when you're forwarding, if you set the DF bit and then you set the so we're not do that, but we're gonna set validate reply data no, data no. If you record the route, so record and then 9 hops, and I'll explain here in a minute why it's 9 hops. And then you type in verbose, and verbose is going to tell you the response for each packet or hop. Verbose, hit enter. And sweep range of sizes, this is going to be where you get into how big the packet can be. So you could type in yes and hit enter, and what's the sweep size? So it could be say 1420, say 1500, and hit enter, and then the sweep interval, where do you want to start? So you're going to say 1420, and there it died out. It's not being able to ping anything. And then you can go through and it's going to die. It's actually going to try to ping 10 times, actually. Control-Shift-6 to break off of that, which is fine. Those are just some of your options you have. Embedded packet capture, we'll take a look at this on the CSR 1000V and on, I don't know if the 12.4 on my 3725s are even capable of this. Actually, you know what? Hang on. Let me jump onto my home router. And we're going to go 22. It should work. Hope it works. While that's doing its thing in the background, we'll keep going. Performance monitor. This is great if you want to see what's going on your network and all the other good stuff that goes along with it. Okay, I had a fatal error with putty. So we're going to say change settings, and we're going to say terminal connection SSH. Alright, so if you go to new session, we're going to say 192.168.1.250 and 23. I'd be mad if it connected. I don't know why I'm not able to connect into the box. Can I ping it? That'll be the $1,000 question right there. I have a lot going on my network. So ping 192.168.1.250. Well, I can ping it. Why can't I telnet to it? Telnet 192.168.1.250. Oh, how bad is that? And so we're going to say monitor. Yeah, it doesn't have. This doesn't have embedded packet capture capabilities. It's got monitor traffic on a TTY line. Yeah, see, I could go in here and monitor anything that's connected to the box, or I could do monitor processes, CPU, and stuff like that, but that's not really going to do anything. Now, NetFlow, however, config T, type in IP flow, and you have all these options here. And each one of them is going to be a bit different. So if you want to do capture, you could do a capture. So capture, and then you could say what you want to capture. So it gives you a lot of options. Now, I would recommend playing with this if you have the option to send it somewhere. NetFlow is only going to be good if you have a collection station to work with. So if I was you, check out a SolarWinds has a free 30-day thing you can download. Performance Monitor, I think it is, or Network Configuration Manager, something like that. Check it out. Or if you have some sort of, like I said, maybe KiwiCat, that's another one I think is out there. But what this basically does is it gives you the ability to point your NetFlow traffic to a internal device and a port number. You specify that information, and then you'll start being able to send traffic there, and you'll be able to dive into what it is and stuff like that. Now, troubleshooting methodologies. If you've never troubleshot a network and you're studying for CCIE, you are going to have a hard time. Now, I've spent the last 2.5, 3 years. That's pretty much all I've done is network troubleshooting of some level or another. And the reason I say that you're going to have a hard time is most of what you're going to do, especially in a Cisco environment. And I hate this, and I'm not talking bad about Cisco. What I am going to talk bad about is the people that run Cisco networks. And I've met a lot of guys that they don't have their. Don't get me wrong. You don't have to be Cisco certified in order to run a Cisco network. I have a CCNP. I'm working on my CCIE. You don't have to be like me. You don't have to go out and get certified in order to work on a network. Hey, although it does, going through the technologies and learning them actually does help. But the idea behind the people that run them, you'll find that if you haven't been formally trained by someone that is Cisco certified, just my opinion, it's you're not as you may or may not have been given tidbits of information that may come in handy. So, not saying that you're any less qualified. It's just, in my opinion, it's just, there's trying to think of a good way to put it. Because I know a lot of guys that aren't Cisco certified that smoke CCIEs, and I know that's a bad thing to say, but it's the God honest truth. Once you get into the real world, or if you're in the real world and you've never dealt with a Cisco person that isn't Cisco certified, you'll find out quickly that people that are Cisco certified have a tendency to stray to Cisco. I know it's just the way it goes. At least in my experience. Everybody's experience is a bit different. But anyway, the idea, it says right here, to diagnose the root cause of networking issues. So analyze symptoms, identify and describe the root cause. So that can be difficult if you don't know how to identify it. And define the issue, gather information, after some research, testing, hypothesis, what are the findings, document the root cause. Yeah, that's great. I mean, that's like ITIL up and down, right? The problem with that is, how do you define the issue if you don't know what's wrong to begin with? And that's where one of my big things is, if you don't know the technologies, and this is where Cisco certification kind of takes a back seat. If you don't know the technology, if you don't know how routing works, how are you going to troubleshoot if it's working correctly? That's one of the main sticking points. That's why I'm kind of adamant about how I teach and how I deliver stuff is based on my experiences. So, if I run into a situation at work and I don't know what the problem is, okay, do I feel stupid that I don't know? No, absolutely not. It's a learning opportunity for me, is the way I look at it. And my boss likes the way I look at things. He says, okay, well, if you could fix it, what would you do? Or how would you go about doing it? Like, well, I'd have to figure out what's going on. And, and sometimes it's just a lack of understanding of what's going on in the network. And you, the engineer, have to go out and figure that out. Whether it's doing a couple show commands, a show run, but all that, even if you know what's going on physically in the network, you can still run into the issue of not understanding why it's there. So, knowing the technology is going to be first and foremost. So, what I have on the screen in front of you is only going to be good if you understand what's going on. If you understand the technology. So, I just want to make that clear. Now, design and implement valid solutions according to constraints. I deal with that all the time. You walk into a network, they tell you that they only have a $500 budget, or they didn't give you a budget. They say, this is broke, this is what you have to work with, fix it. And you're like, yay! What do I got to do? And you jump to it. If you understand what's going on, technology-wise, you're that much better off. So, using the diagnostic aspects, you'll be able to formulate, design a fix, and apply it. So, let's say you're having issues with really slow internet. Okay, do a speed test. Speedtest.net. What are you getting? What's supposed to be? So you go out to speedtest.net and you look at it and you go, okay, I'm supposed to be getting, 15 megs down, 2 megs up. Okay, I have cable here at home, so that's what I run. Does that mean that you're going to have 7 megs down, 200K up? It could be, but that'll at least point you in the right direction. Now, Now, specifically with slowness, what kind of slowness? I get this all the time. I'll have an IT person at a remote site email me and go, "Hey, we're experiencing internet slowness," and that's all I get. I'm like, "Okay, great, thumbs up, thanks for the update." What type of internet? What slowness are you getting? Internet. Describe it. Are you half loading web pages? Is it email? Are you trying? Then I'll look at the device. What's uploading? I'll look at top talkers and we use PRTG, and I'll dive in. I'll say, what's the upload look like? What's the download look like? Do we have a lot of top talkers in the network? These are all things that you should be able to go through and go, oh, okay, I got it. But being able to isolate and remediate, that can be more difficult than it sounds. So, depending on your devices and depending on what's going on in the network will determine how that actually works. So, now, this is kind of a key feature right here. Make sure that the solution doesn't violate or impede a restriction or break a policy. That's going to be kind of key. Even when you're in off hours, technically, you're still constrained to what you can do. Unless there's, in the company I work for, we do a lot of pre-planning. My boss will call me up, but we'll spend 45 minutes on the phone hashing things out. Okay, what do we do this? We'll talk about stuff. And that's one of the things I really like about my boss and my coworker. I can sit there on the phone with him for 20 minutes and talking about one specific thing. Okay, for instance, we're getting rid of BGP in my network. We don't want to run BGP. We have IPsec VPNs to all this from a couple of sites at our primary locations, our core locations. If they're, say for instance, we have an office in Orlando, we have an office in Miami. Well, we have VPNs between Miami and Orlando, and we also have VPNs between Miami and Milwaukee and Orlando and Milwaukee. So if the primary circuit goes down, which is what the VPNs run across, then things will fail over to the backup circuit, and everything will be fine, right? Well, that's great, but he'll ask me, okay, if we have a primary circuit go down at XYZ location, what's the failover going to look like? It's one of the things we test, and I can't go in and when I might be remoted into a switch that's running EIGRP, and I can go show IP EIGRP interfaces, and I see all these interfaces that are running EIGRP, and I'm like, that's not supposed to be there. That could be that. We should turn that off. And we're doing auto summarization. We don't need that running. We need to have no auto summary. Things you'll see as an engineer that should technically be turned off or on, and you say something. I was like, oh, well, don't mess with that because you might lose reachability to that device, and there's nobody on site to help you out with that. And you're like, okay, so it could be a reachability issue. It could be a network-based situation. You have to take those things into mind before you do something. You know what I mean? Verify and monitor solution. Like I said, with the whole voice over IP thing, we didn't just do something and assume it's going to be the one and only fix. That's just not a smart move to do. Because if you do that, you can run into problems later on down the road. So, monitor the solution, see if it works. Now, I know a lot of guys that have taken the CCIE lab exam, and even though it says, let me qualify the statement. You're not supposed to use static routing in the troubleshooting section. So, unless it states in the troubleshooting section not to use static routing, don't use static routing. But it doesn't say you can't use static routing to verify a theory. So I do this a lot. I'll place a static route somewhere and I'll test it. Okay, is that what I think is going to happen? And if it validates my theory, and I'll tell my boss I'm going to do this, and I'll tell you, and he'll be like, "What's it going to do?" Well, my theory is this, and if it does do that based on this, then I know that if something else kicks in, this should work. And he'll be like, "Okay, try it out." And it's knowing how things work what helps. So now let's take a look at interpreting packet captures. Now, reasons for a protocol analyzer. I live on Wireshark, and we'll take a look at Wireshark several times throughout this entire series, or into the lab series, not so much through the written series. But baseline, it's great to see what's going on. I do packet captures a lot just to see how things are working. and you get an idea of what's going on. It's great to see why and we use packet captures to figure out our SIP deployment. Why did things work the way that they did? We didn't know why. We just, it was good to know we could go to a Wireshark capture and see what's going on. Verification and learning. So being able to verify a proof of concept to executives. So, I just started a project where we're deploying a SIP-based provider at every location that's remote to us. So we don't want to have Cisco Call Manager traffic going across our VPNs back to our headquarters sites. We don't want that. We want to have SIP-provided phones on site. Takes the worry out of me. Well, I have 45 remote sites on my network, so that's a lot of remote sites. That's a lot of verification. So I had to do packet captures on some stuff. We had a couple test phones in some locations just to get an idea as to what was going on, and it was one of those things where, I needed to do some things, and packet captures were a great source because I was able to show them before and afters, and they were like, okay. And because I was able to put a visual reference in front of them and some graphs and some pie charts, executives love pie charts. They were like, they gave me the thumbs up, and now I've got to deploy, 600 SIP phones in the next 6 months. Yeah, that's a lot of work. Most of the infrastructure is already in place with PoE, so it's going to be just pretty much the plug and play. It's just a matter of getting SIP and the routing in place. But methods for getting captures, Wireshark is going to be the primary thing. Now, I use Wireshark for everything. It runs on Linux, it runs on Windows. There isn't a thing that it won't run on. You can do SPAN, which is switchboard analyzer, which is going to be on the local switch. So you say you have fast Ethernet 0/1, and on the same switch you have fast 1 as the source and fast 2 is the destination. You plug in your laptop into fast 2, and then you have that as the destination port. Anything that comes in fast 1 gets mirrored to fast 2. So it's great. Then you have RSPAN, which is going to be remote span, which means you're going to have span traffic going across a trunk between two different switches. So switch 1, fast 1, is going to be the source port. Then you're going to have a trunk that's going to be allowing span traffic. And then on switch 2, on fast Ethernet 2, you're going to have that as the destination port. So it's a little more configuration. And then ERSPAN is what they call extended range, or extended remote span, where you're actually going to tunnel that RSPAN traffic over a GRE tunnel to another location, and that you're going to drop it off at a remote site. So, assuming that your network is not layer 2 end-to-end. So, using a Wireshark trace analyzer, we'll talk about that in a lot of detail when it comes up later on. But it's going to be one of those things that's very, very cool once you actually get into it. Now, iOS embedded packet capture, I don't actually have the ability to fire that up right now because I don't have a CSR 1000V running. But if I did have embedded packet capture, I'll look through that. It gives you the ability to see what's going on, but it's all hexadecimal output if you actually capture traffic and you want to see what it looks like. And then you can actually export that using TFTP to a TFTP server. And I'll show you how to do that. It's actually really, really easy. If you've ever TFTP'd an iOS image from your TFTP server to your device, it's the same process, except for the simple fact that you're TFTPing like the running config to a backup config on Flash. So saying copy run start, you copy run TFTP, and it's saved on a device locally. So that's pretty much everything I had for you when it comes to this. It's actually really, really simple when you think about it in all essences. But that's pretty much the extent of what's going on. If you have any questions, feel free to drop me a line. But beyond that, a couple of things that I have here that I'm not going to go over is network implementation and operation. So we're not going to look at this in this video, and then evaluate proposed changes to a network. When we get into going through, distracted with email. When when we get into the actual implementation of things, we look at protocol parameters, things like that. That's where we're going to take a look at. If you're going to be migration, that's where this is going to come into play. But beyond that, that's pretty much all we're going to talk about in this video. I hope this has been informative for you. I'd like to thank you for viewing.